All right. Well, we're up to 28. Come on, 2 more people. Let's make it an even 30.
I believe Debbie Vaughn mentioned in an email today to Richard and I that there is an ISS, International Space Station pass, starting at 8:46, I think. Let me go to email again here. 1 second.
I saw 11 a.m. and I was like, no, that can't be right. And I thought, I was in the middle of work stuff. So I thought, well, I bet.
Yeah, 8:36 p.m., visible 4 minutes, height 79, appears 29 degrees above northwest, disappears at 16 degrees southeast. So I think we were thinking about potentially doing everybody go outside for a hot minute and go take a look. I'm hoping this will work. I'm going to see if I can get Zoom to attach to my phone and maybe be able to get some footage of it for the actual meeting. We'll see if that works.
At 8, what was that time again? 8:36?
Let me go ahead and post this to the chat window.
8:36, I see that. All right.
There it is.
Should we set an alarm?
I sent it to Mark privately by mistake. There we go. So we are the planetarium. The college has an enterprise edition. Bob was asked, are we paying for upgraded Zoom? We're actually hosting it, and we figured, well, since we host you all for physical meetings, why not host you all for virtual meetings? And we have a lot of features that even the pro version doesn't offer. Including unlimited participation and things like that. So,
even the pro version? What comes after the pro version?
There's an enterprise version that has all these other like security things and things like that that even the pro version doesn't have. So, yeah.
Well, it's 7:02. Technically, we have 33 participants. We should probably go ahead and start. So. Welcome to the very first virtual CFAS meeting. I'm sure a lot of people are having their very first virtual meeting this month. I am not going to give you a big speech about these troubling times and blah, blah, blah. We all know the mess we're in. Some of us, we're dealing with it the best we can. And so we're not going to dwell on that. We're going to talk about this for escaping from all that as best we can, and hopefully we can entertain you better than Tiger King on Netflix or something for a little bit and talk about astronomy stuff. So we have Brandon Byrne, who's going to be speaking about astronauts and how they deal with isolation. I think it's kind of funny, astronauts have to stay in a little room for a long period of time, and a lot of us are getting a taste of that. My sister is actually lives in Indiana. She's in an assisted care facility, and she's like quarantined to her room. So she doesn't have a house. She's like in a room, like she's on an astronaut going to Mars. And a lot of people are handling that less as well as they might on a real spaceship. At least you can look out the window and go out in the backyard and that sort of thing. So here we are. So Brandon is running a few minutes late, and that's fine because this is all virtual. We have a number of mini programs lined up, including some what's new in the sky tonight and news about what's going on with Comet Atlas and so forth. And so I'm going to go ahead and start with the Astronomy League Observing Certificate. Let me, let's see. I just did this yesterday. Share my screen, desktop 2. There we go. And I'll start talking. So the Astronomical League observing programs, there are many of them, and every month I'm going to highlight a new one. Last month we started with globular clusters. I've added a few things to the standard slide sets, like why should you do this? Well, you get a pin and certificate, so you get bragging rights and personal glory. You can show up at the astronomy club with your hat and all your pins on it, or your shirt, and you'll look like a 6-star general with all of your observing accomplishments. After all, this is the Astronomy Club. We want to be amateur astronomers. You are not an amateur football player by watching football, so you should do a little bit of astronomy, at least do some observing and learn about different types of objects. And this is a great way to do that. There's nothing like having a structured set of goals and a scaffolding to do your learning. Most of the observing programs have some reading material, or they force you to do just a slight bit of research, learn how to read a star atlas or a moon atlas and things like that. And you can do it by yourself. You don't have to wait for a big group of people to all be off work the same night. You can just go, hey, Saturday night I'm bored, and hey, I'm going to go work on my certificate because it's nice and clear. Of course, you can do it at your own pace. I'm working on several of these certificates myself. Some of them I've been working on for multiple years, but that's great. I can do it at my own pace. And of course, it advances your skills and knowledge. I mean, after all, why do we have hobbies if we don't want to do anything or learn anything? So this month's observing program is my favorite one, the Lunar Observing Program. Why observe the moon? Well, it's available whenever the moon is up, which is kind of a funny thing to say, but when we talk about astrophotography or observing, there are certain things that are summer objects or winter objects, or, well, the moon's up, we can't do any observing. And I'm like, you can look at the moon when the moon is up. Why not shoot the moon? Why not look at the moon? Anytime the moon is out, the moon is actually available. Well, what about if you live somewhere where there's light pollution? Who cares? The moon's like honey badger. It don't care if there's light pollution, does not care. Live in a city, so what? Go to the roof of the apartment, go out on the balcony. You can observe the moon anytime, anywhere. Well, we got to have great weather. You got to have all those blue blocks on the clear sky chart. No, you don't. A little bit of hazy is also no big deal. You can look at the moon through some thin clouds very easily and still identify features and see things that are going on up there. What about if you don't have a telescope? Well, it turns out the Lunar Observing Program has 3 tiers. There's naked eye, and there's a binocular certification that you can earn. The naked eye objects are required for all certificates, but if you don't have a telescope, you can use just the binocular. You can just do the binocular targets and do it. So what you'll do is you'll record your observations. You write date and time. You're going to learn how to judge the seeing and transparency, so you record that. You also record your latitude and longitude for when you observed the feature. And there's 100 features. Some are naked eye. Some you find with binoculars. I love lunar rays. If you see any rays at all on the moon with binoculars, there you you can also use a telescope for the full lunar observing certificate. And all of the features are available through a 60mm refractor. That doesn't mean you have to have a 60mm refractor. What that means is that red plastic telescope out in the garage surrounded by bug killer and lawn gear, get it out, dust it off. That's perfectly capable of finding all of these features on the moon that are a part of the Lunar Observing Certificate. So get out there and do it. They also have some kind of fun extra credit activities. You can, plot the moon's position against stars or estimate the phase, and you can count those as specific feature items to put in your list as well. So that's it. These are very short. Each one of these programs is pretty short and simple. Just go through a catalog and learn something about the objects. And in this case, it's the moon. Learn quite a bit about the moon and the things that are on the moon. If you want information, you can go to the Astronomy League website, which is astroleague.org, or you can talk to or email the CFAS Alcor coordinator, which happens to be yours truly. And if you're ready to submit, you can also submit your observing logs to me, and I'll take care of it for you. Or you can actually submit them directly to the Alcor program coordinator. I think it was last month when I did this, someone brought up that in the past, you could not submit directly to the Alcor. I did look that up, and you are able to do that now. You probably weren't able to do that in the past, but it clearly says, you can send it to your club supervisor, or you can send it to the program coordinator and then tell them who you want your stuff sent to. So also, if you send it in yourself, you can have it sent to me, and we'll submit it, you know, at our next program where we can all get together, which hopefully will not be, you know, years and years in the future, and we can embarrass you, and maybe we'll have a special hat or something that we can put on you and say, yeah, you're a great observer. And that's it. That's all I have.
Richard, we had one question from John. He was asking, should we recognize members who got a certificate in the program from the previous month as people start getting them?
Yes, we should. In fact, I'm glad you brought that up, because Eric Hoyne just recently earned his Master Outreach Award. Lynn Ward was awarded that quite a bit back. Eric Hoyne got it. Now, to be honest, Eric Hoyne earned this award like 15 or 16 years ago. He turned in all the paperwork about 2 or 3 years, well, not two, about a year ago, and some slacker, we should fire him, but lost it. And anyway, he got his much late, but he's a champ about it. And that's the highest outreach award you can get in the Astronomy League. And that's the only ones I know about, because those are the ones that came through me. You're welcome, Eric. Thank you for all of your help. I know you helped Lynn a lot with a lot of events, and you do your own events. And you've come out and helped me with Coffee and Cosmos many times as well. So sometimes you're the only help I've had. So I appreciate that greatly.
Oh, you're welcome. It's a passion.
Yeah.
It's certainly well worth it. And thank you and Derek for putting this this meeting together tonight.
Oh, you're very welcome.
I think Derek and Justin did most of the work.
Thanks, Justin. Where's your helmet?
Yeah.
That was great, Friday.
Real quick, since some of you didn't attend the training session yesterday, what we're going to be doing, as you can see, Justin is going to be handling our question and answers. So if you have a question for any of the presentations, go ahead and put that in the chat box there, and then we can answer those questions after the presenter is done. If, for example, when Brendan gives his talk, somebody asked if we have a question that's pertinent to whatever he's talking about at that time, you can interrupt, and we can do that. But if you have a question that can wait till the very end, it would be better to do it that way. And we'll be doing it through the chat box, just because we want to make sure everybody's muted. The reason for that is that usually there's a dog that barks in the background, or there's somebody coughs or sneezes, and all of a sudden it shows your screen instead of the person who's presenting. So we're trying to avoid any of those type of things. So we really appreciate all of you keeping everything muted through the time that we're speaking, so to make sure that we won't have any interruptions. But of course, if you're mentioned, or if you want to bring up something real quick, you can go ahead and unmute yourself, and then once we're done.
Cool. Thanks, Derek. And so actually next, I think we'll have Justin talk about what's new in the space world. And Justin, while you're talking, I'll try to keep an eye on the chat for you in case anybody has any questions about what you're talking about.
Sounds good. Let me just switch over here. How's that look?
Looks great.
Okay, good. Yeah, so on Thursday nights, we've been running a virtual planetarium show each Thursday for the public as part of the planetarium outreach. Since obviously people aren't able to come to the planetarium, we're trying to bring the planetarium to them. And we usually will do a program about some particular topic, and then I'll finish up the show with just kind of what's up in space exploration, make sure people are kind of up to speed on what's going on. So many of you might know a lot of this is going on already. Some of you may not, and some of you might learn something here. So I'll just blow through these real quick, but this is just a sample of what we're giving out to the public during our shows. Just well, I guess it was 2 weeks ago, Space Force officially launched their first rocket in partnership with ULA and NASA, and this was a beautiful daytime launch, and it was the inaugural flight for this new branch of the military, United States Space Force. The rocket had the beautiful new logo plastered all over it, and this was the final of 6 communication satellites that were going up in orbit. And right around this time is really that end of March, where coronavirus was really kind of exploding around the country, and they decided to proceed with the launch anyway. The military considered this a kind of mission critical, that this launch needed to happen. So that went up. The image you see there is from one of the remote cameras. A local photographer, Michael Kane, was able to just get that fantastic shot of that rocket going up. So all future Space Force launches for the military will have be part of this new system, this new network, and this new branch of the military. They will be, as far as it's scheduled right now, the X-37B launch is still planning on going up in May. So that will be another kind of mission critical flight for the military for launch. So we'll keep an eye out for that. Artemis is still moving forward. Last week also, the Orion crew capsule arrived back in Kennedy Space Center from Ohio's Plum Brook Station, and it was undergoing a series of tests in their vacuum chamber there. The vacuum chamber kind of simulates temperatures in the vacuum of space, and it was undergoing those tests back October, November of 2019, and was delivered by that nice propeller-driven Super Guppy there that you see, and it's going to continue moving forward. The tough part, though, is that even most of the SLS system is built, but it's still undergoing a massive amount of testing, and it appears that coronavirus is going to interrupt that testing. So I guess we'll just see where this is going to lead. NASA was planning on, the Artemis 1 mission, which was the uncrewed flight around the moon in 2021, and then a crewed test mission around the moon in 2023, and then a landing was planned for 2024. So we'll see where this goes. But Artemis is still kind of crawling forward, and Jim Bridenstine has been very vocal on social media and the news on how this is a big priority for the U.S. government. So we'll keep a close eye on that. Kind of the highlight for the summer is going to be the SpaceX Crew Dragon Demo 2 launch, and that is still currently scheduled for May. The original date was, I think, May 7th, and it got moved to May 15th. They've dropped the actual date now, and they're just reporting May of 2020. But so far, it is still on schedule. Now, this is going to be a pretty historic launch. This is the first time since 2011 that American astronauts will leave American soil to go to the space station. It will also be the first time in history that it was done by a commercial program. So pretty exciting. We got real lucky, and Derek and I were approved for press credentials for this launch. So if it does go up in May, hopefully we'll be there to capture as much of this as we can for the public, for the planetarium. About a week ago, they put the retro NASA worm logo on the Falcon 9 booster, so that was pretty exciting. And they've been publicizing quite a bit that Doug Hurley and Bob Behnken have been going through a lot of rehearsals, getting ready for this just monumental launch in May. So I can see this being even bigger than lines of thousands and thousands of people going out to the Cape to watch that first Falcon Heavy. This will be even bigger. So keep an eye on that. See if that goes up in May. In July, we've got the launch of Perseverance, and this is the next generation Mars rover. It's very similar to Curiosity. It's just got a few next generation tools on it. Again, it's looking for conditions for life. It's going to be landing in the Jezero crater in February of next year. And we're going to be doing a show about this one tomorrow night. So if anyone's around and you're bored, we've got a Mars show with one of our colleagues from North Carolina at 7 p.m. if you want to dial in and watch that. But Perseverance, it's pretty exciting. It's got some cool tools. Its primary mission is to take 31 different core samples of Mars, and those core samples will be picked up at a later mission and brought back to Earth. The coolest feature about this rover is it has a drone helicopter that will disengage from the rover and will survey the Jezero crater and around, looking for the best dig sites to take these 31 core samples, store them, and bring them back to Earth. So a lot of cool stuff there. Keep an eye out, and if you can get out to watch that launch, that'll be pretty historic also. OSIRIS-REx has been orbiting asteroid Bennu for about a year, and they are about to begin, I think it's April 24th, their first practice run of a touch and go off of the asteroid. And they had chosen 4 different sites: Nightingale, Kingfisher, Osprey, and Sandpiper. They decided to go with Nightingale, and then Osprey is kind of the backup site if they need it. But beginning this month, OSIRIS-REx is currently orbiting the asteroid about, I think, between 1 mile and 5 miles out. And it's been surveying this asteroid for well over a year. It's already found some fantastic science in clay deposits. So we know that there's a lot of evidence of water on this thing. What's going to happen is the OSIRIS-REx spacecraft will kind of bounce off of the asteroid, and when it does that, it's going to kind of reach out with this. It's called a TAGSAM arm, and what it does is it kind of blasts some nitrogen through it, and it collects the regolith off the asteroid. And once it does that, it will send this TAGSAM head back to Earth, and it's scheduled to land in the Utah desert in September of 2023. All of these practice runs are going to start this month, and I believe that last I read, they were shooting for June or July of this year to actually do the touch and go and bring this stuff home. So keep an eye on that in the news. That should be pretty exciting. This will be the first time that an American space company has done this. JAXA has done it twice now with asteroids that they've been on, but this will be the first for NASA and OSIRIS-REx. So pretty exciting stuff. Just some stuff to do if you're bored and you're looking for space-related stuff. There's a lot of fun stuff out there. Brendan Byrne, who's if he's not on already, he's joining us tonight. He has a wonderful podcast called "Are We There Yet?" It's on WMFE on Tuesdays at 6:30, and it's a half-an-hour show. And he just does an incredible job getting fantastic guests on the show, current and former astronauts, mission control, you name it. Just a wonderful podcast, and you can download his older episodes too, and they're all pretty relative because a lot of these space missions are 5, 10, 15 years out, so a lot of cool stuff there. Everyday Astronaut is done by Tim Dodd, and he's a lot of fun to watch during launches because he just adds a nice narrative to the launches as they happen. And he's kind of become a little bit of a mini celebrity when it comes to social space, social media, making space fun and interesting. And then Walk About the Galaxy is just a great podcast that's put on by the physics department at UCF. Many of you probably remember Addie Dove, who's spoken at CFAS meetings in the past. She does this with Josh Caldwell and Jim Cooney at UCF, and they just talk about this one's a little bit more science detailed because obviously that's what they're doing day in and day out, and it's just fantastic detail into what they're working on. And they've had science missions on both SpaceX rockets, Blue Origin rockets, so you're kind of hearing right from the source of this cool research that's being done, science that's in progress moving forward. If you don't have it already, there's a free coupon code on CBS On Demand. If you put in GIFT, you get CBS On Demand for free until April 30th. And Christine and I have been catching up on old Star Trek episodes we've missed, and Picard is highly recommended. So if you're a Star Trek fan. Now keep in mind though, this Star Trek Picard is not your classic Star Trek. It's a little bit for the mature audience. It's pretty violent actually, and it's got F-bombs dropped left and right, but it's really cool. If you're a Star Trek fan, it's a lot of fun. And then Star Trek Discovery is also out there to watch. So free entertainment, right? Who can pass that up? If you've got some streaming services, Netflix or Prime Video, Mars Season 1 and Season 2 is on Netflix. Just a fantastic show that is kind of a docudrama. It kind of intersperses fantasy of us going to Mars in 2033. But what they do is they jump back and forth. They jump back and forth to 2033 and then the present, and they talk with current scientists and science educators on the challenges we'll have, not only going to Mars, but surviving on Mars and building industry there. In addition to Mars, you've got Mission Control, awesome documentary about the people behind the scenes of the launches, the series, The Universe, and Death Dive to Saturn is pretty new on Netflix, and that is the whole Cassini, putting Cassini to bed after its wonderful time and the science it brought back from Saturn. On Prime, you've got The Expanse. This show is kind of turning into kind of a cult following. It had 2 seasons and then it got axed, and then it was so popular with Jeff Bezos, he made them bring it back, and so they're making more episodes, and it's based off the book of the same name. They have How the Universe Works on Prime Video, which is just a fantastic series. So a ton of cool stuff to watch, space related, if you're there bored. Cosmos Season 2 is out now, so that is on Fox and Nat Geo. We've been streaming that on Monday nights at 8. And then Who Can Resist Wall-E? If you've got Disney Plus, throw that on for some fun stuff for the. If you're into some games, Kerbal Space Program is awesome. This allows, it's kind of a flight simulator for rockets. You get to build your rockets. You're kind of given a budget and equipment. You get to build your rockets and then test them out. And if you don't do it right, guess what? They blow up. So it's a lot of fun. You can download it on Steam or on the Kerbal site. And then lastly, if you're around this weekend, you've got nothing to do. Saturday is the kind of global live stream of Yuri's Night. And they've got I guess Yuri's Night was planned here at Kennedy Space Center on, I think it was originally it couldn't have been the 12th. I think that was Easter, but might have been the 11th. And that's usually a $50, $75 ticket. And you get to go into Kennedy Space Center and party underneath the shuttle there. But because of the predicament that we're in worldwide, they've got it all going live stream, and they've got Scott Kelly, Chris Hadfield's going to be there, Nicole Stott's going to be there, and a bunch of different celebrities like Rod Roddenberry and Bill Nye. So it's all free. You can log in and party with a bunch of space geeks like ourselves. So, and that's it. Lastly is NASA.gov has this wonderful site called NASA at Home. So if you've got little ones around, or you're bored yourself, or some grandkids, this is a great site, just a wealth of resources for videos and ebooks and podcasts. They just kind of aggregated it all here so that you can easily find a bunch of fun stuff to do during this time at home. So that concludes my presentation.
All right, thank you very much, Justin. That's pretty cool. Before we start our next program, all right, we're up to 41 people. Yay! Oh yes, let's all give them a hand. There is a little clap thing down at the bottom. Clap, clap, clap. Have we heard from Brandon yet? Do we want to let him go on next, or should we go to Derek's Night Sky Talk?
I don't see him on yet.
Okay. Brandon, if you're here, speak now or hold your peace for 10 minutes. Okay, Tricia says he's not here yet, so we'll go ahead and we'll transition over to Derek's Night Sky, what's going on in the night sky tonight, virtual planetarium show.
All right, so we've been having some really nice sky conditions for the last week or so, and we have some really interesting things to look at in the sky. So we're using Stellarium, actually the same software we're using for our virtual Star Party programs as well. So for those that were tuning into those, you pretty much will kind of have an idea of what we do here. So what I'm going to do is I'm actually going to turn over to the western sky, because we have some objects in the sky right now. So right now we have the sky set to, actually I'm going to go back in time. Originally I had this set to 9 o'clock. I'm going to go back to 9 o'clock here. And this is what the sky will look like around 9 o'clock. Astronomical twilight's around 8:30. So just going a little bit ahead in time for us. But you'll start to see, we're going to start with the west because obviously one of the things that a lot of people probably hear their neighbors talk about. I know that when I go outside and I see people walking at night, they kind of are starting to realize that I'm the resident astronomer in the local neighborhood, and they go, "Hey, Derek, what's that big bright object over in the west?" And of course, we know that as Venus. So, of course, Venus last week has been really, really nice because it has passed by this little cluster, the Pleiades, and we have some photos of that in the astrophotography showcase later on. But of course, Venus is a really great target to look at right now, especially if you want to do some planetary viewing. It's a beautiful phase right now. It's pretty much almost a quarter phase. I always love looking at Venus in a quarter phase because it really shows you that it's a planet, and it shows how, you know, it's the direction of the sun and all that. So it kind of helps demonstrate to people that the planets do, in fact, go around the sun. Actually, Galileo utilized the phases of Venus as another evidence point to that we are in a heliocentric model. So kind of an interesting thing. So Venus kind of gets overlooked a lot. Usually people mention the moons of Jupiter, but the phases of Venus also look good too. And now I'm not, for some reason I noticed with Venus is I don't believe it actually shows the clouds of Venus in this. Oh, it does. Okay, it doesn't. It shows the clouds, but it does show the phase. So it's kind of cool to be able to show you Venus without the clouds. Of course, this is the Magellan data points, the radio data points from the Magellan space mission. But you can see here again, Venus is in a very nice phase, and again, a nice target to look at as the sky gets darker. And you begin doing some observations of the night sky. So, and if you have a pair of binoculars, you know, you can still scan Venus and look down just below it, and you can see the Pleiades. So speaking of the Pleiades, of course, we'll talk about that next. So the next object that we want to look at is this one right here. So right next to Venus, we have the constellation of Taurus, the bull. So there we have Taurus is, you know, kind of drawing here. There he is charging after Orion. And we'll put the labels up as well. Of course, a couple of things that we can see in Taurus right now is, well, first off, just below Venus, we have the Pleiades. So we're going to go ahead and center on that. And we're going to go ahead and zoom in. We can take a look at the Pleiades there. So the Pleiades are a very, very nice open star cluster. Great object to look at with a pair of binoculars or a very, 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 very wide field telescope, like a small refractor or a small Newtonian or something like that. And you can even see the Pleiades just as nice during a full moon, which we had last night. So tonight, if it's clear out and you get a chance after the meeting, go outside and do some observations of the Pleiades. The other thing that we can see, let me go ahead and get rid of the artwork here, is I'm going to go ahead and type M1. There we go, M1. All right, so located here just next to this star in Taurus's upper left horn, Alnath, we can see is M1. M1 is a beautiful supernova remnant and a great target to look at with a telescope. Of course, with the quarantine going on, a lot of us won't have access to going to dark sky sites. But what we are hoping to do, and something that I will make a mention real quick, is that we are looking at potentially doing a private CFAS virtual star party sometime in the near future, almost like a mini Astrofest, which hopefully we might be able to have a few of us that do live stacking or our astrophotography to be able to show us some of these really cool objects, especially the fact that we're in light pollution. But if you have if you have a fairly decent dark sky, you should be able to still see M1 fairly well. Now, just above Taurus the bull here, we can see this beautiful star, Capella, very nice bright star in the sky. And surrounding that, we have the pentagon shape of Auriga, the charioteer here. So there's Auriga, the charioteer. Legend has it that basically the reason why he was placed in the sky is because he actually saved a bunch of goats from a fire. And that's the reason why he's holding a bunch of goats. So people always wonder, why is Auriga holding a bunch of goats? And throughout all of this part of the sky here, we have some really nice star clusters. So we have M36, which again is a open star cluster here. So we zoom in, we can see the open star cluster here of M36. We also have another great target here. I gotta do it this way. M38. There we go. And that's another great open star cluster to look at in Auriga, the charioteer. So lots of, now these are both great objects to look at. There's also M37 as well. All of these are really great to look at in the night sky with the moon up. Now, if we continue down towards, back to Taurus here, and we continue over to the southwest, we will see our favorite hunter of Orion right here. And of course, Orion is still nice and visible up in the sky in the early part of the day here. We have Orion's belt, Alnitak, Omnium, and Mintaka. We have the nice bright star Betelgeuse. Betelgeuse is starting to brighten up again. Here we have his head, the star Bellatrix, Rigel, and Saiph. And located right here is, of course, the Great Orion Nebula. The Great Orion Nebula is just below Orion's belt. And if we zoom in there, we can see there is our beautiful Orion Nebula, a great target to see even in suburban skies. You can get some really nice nebulosity surrounding what we call the trapezium, which are about 30,000-year-old stars, very, very hot, very luminous, and are exciting the gases surrounding it, creating a nice glow of gas and dust that we see with the Orion Nebula. So again, so those are pretty much a lot of the objects that we can see in the western sky. If we go up here towards the zenith, we'll notice there is Gemini, the twins, Castor, and Pollux. People always ask, how do you know the difference between Castor and Pollux? Well, I'm kind of dyslexic, so left and right don't work really well for me. So what I use instead is that this star, Capella, is closest to the right star of Gemini, and of course, Castor, which by the way is a 6 six-star system and a sextenary star system, which is also a great object to look at through a telescope. That one is closest to Capella, so the C star, Capella, mixes with Castor. Over here, just to the left of Gemini, is the little constellation of Canis Minor, and the star, the brightest star in Canis Minor, is Procyon. So Pollux, beginning the letter P, is a great way to connect those two together. So the star closest to Procyon with the letter P is Pollux. So that might be another helpful way for you to remember the names of those two twins, Gemini. And located near the foot of, located in the foot of Castor is M35. M35 is a wonderful star cluster to look at as well, especially star clusters work really well even in full moon nights. So you got a lot of different star clusters to look at in the sky right now. Again, that's located just near the foot of Castor right there. And if we continue up towards the zenith even more, we'll eventually see Cancer. Cancer is pretty much almost straight overhead this time of year. And located in Cancer, here, now Cancer is kind of a harder constellation to really pick out. It's really difficult to kind of see the pattern of Cancer, but but one of the objects that we can really see in Cancer, whoops, that's the wrong one. That's Pleiades. I meant, I'll just do it this way. Oh, it's not showing up. I think it's M40, M54, I think. Nope. Darn it. I'm drawing a blank right now on I think it's I thought it was M45, but it's not. Does anybody know in the chat window which one it is?
M44.
M44, thank you. Yes, M44. There we go. Yes, thank you. So here we have the Beehive cluster, also known as Precipice, or the Manger. This is another target that you can see very well in a pair of binoculars. You don't need a very large telescope to see this star cluster here. Now, if we continue over to the left, more towards the kind of eastern part of the zenith, we'll eventually see the constellation of Leo, the lion. So here we have our picture of our lion there. He's the Nemean lion. He was one of the adversaries, one of the labors of Hercules, and he wrestled the lion to death, and eventually Hera, the queen of the gods, placed Leo into the sky as we see him today. But some of the most prevalent stars in Leo, of course, the star just below his head here is Regulus, the heart of the king. Easiest thing to pick out Leo's head is kind of look for a Captain Hook, pirate hook shape, or some people like to call this a backwards question mark. Down over here, we have his these stars for his body right here. And over here on the far left, we have the star Denebula, and that is the Beta Lioness, or the second brighter star in Leo, the tail. Literally translates the tail of lion. Now, one of the things that we can look at in Leo, just below his back here. So if this were his back, these two stars right here. If we would treat this like a triangle right here. The right angle side of this right triangle, if we look just below it, we can see what we call the Leo trio. But unfortunately, this program only has M65 and M66 listed in here, not the Hamburg Galaxy, but of course the Hamburg Galaxy would be kind of over here in this area. This is a nice cluster of galaxies that we can look at in the sky this time of year as well. So great objects to look at right now in the sky, again, just below Leo's back there. Now, we're going to go ahead and move over to the northern sky here. And what you're going to notice, of course, is being that we're in the springtime, the Big Dipper, or Ursa Major, the Big Bear, is very high above us. And we have some really great targets to look at. Of course, we can see the Dipper right here. Here's the bowl. And here we have the handle here. A couple of objects we can look at is we can look at M81 and M82. These are Bode's galaxy and the Cigar galaxy. So if we zoom in here, we can see both of those. So here we have M81, Bode's galaxy, which is a nice spiral galaxy. And we have M82, which is the Cigar galaxy. And that's basically looking head on. Two great, nice looking galaxies, even really nice to look at under light polluted skies if you have a fairly large telescope. If not, you might want to see if it down the road to look and getting into a little bit darker sky to see both of those. The other thing we can look at in Ursa Major is, of course, M51, the Whirlpool galaxy. We have this. We have these stars in the Dipper Alkaid here. Alkaid, right next to Alkaid is M51. And so you basically go down towards the handle of the tail of the Big Dipper or the Big Bear, and you just kind of go off to the right of it, top right, and you'll see, of course, you'll find M51, the Whirlpool galaxy, a nice spiral galaxy with a companion galaxy being merged in there using tidal forces there. The other thing
Derek, real quick, Len had mentioned if making sure that the NGC catalog's on might show those missing items.
What's that? The NGC?
Yeah, if you can verify the NGC catalog is on. Looks like it is, though.
It is, yeah. So it says here M51 and NGC 5195.
Yeah. Okay.
So, and of course, you can look that up too through various databases. But now, the last thing I want to mention tonight, since we only have so much limited time, is located here is this little tiny constellation called Camelopardalis, which is basically the giraffe. There we have our giraffe here. And in the neck of Camelopardalis right here, we have Alpha Ursus's Dubhe here. If we take Dubhe and we kind of head towards Polaris, actually these are the pointer stars Merak and Dubhe of the Big Dipper here. If we point those over down towards Polaris here, the North Star, kind of over just above it, if we go above it this way towards this star here in Camelopardalis, it doesn't really have an actual name, but this area here, what I like all of you to do is scan your telescopes in this general area of the sky. And this location is the location of Comet Atlas C9 2019 Atlas Y4. And that is the comet that's currently up in the sky. And Frank is going to be showing you all some of the images he's taken of Comet Atlas during our virtual star parties and talk a little bit more about that in his presentation. But basically, you kind of want to scan in this part of the sky here using Polaris as a guide and Dubhe as a guide. Kind of jump down to Polaris just above that and kind of scan in this area. And you're going to see kind of an out of focus fuzzy star in the sky, and that is going to be the star or the comet. Now, what I'd like to do real quick before we end here is I'm going to go to the early morning sky. So we're going to go to about 5 o'clock in the morning, and we're going to look to the east. And you'll start to notice here in the east, we got the nice, beautiful summer sky, and we have a nice line of planets. We have Jupiter, Saturn, and Mars. So if you are somebody who likes to get up early in the morning, I actually got up early this morning to image those because unfortunately it looks like the forecast for this Friday for our virtual star party isn't looking very good. So I decided to cheat a little bit and get some footage and images of those to show during our event. But if it's clear out, which it normally is in the morning time, be sure to go outside and take a view of these 3 planets in this nice row in the sky. And of course, the planets are going to get better and better as we move in, or up earlier and earlier as we get into the summer. And hopefully, we might be done with a lot of this by the time maybe in the fall when these planets will be up during the evening. And hopefully, we might be able to set up a outreach event or a observing event where we can look at these all together again in person. So. All right, so that's pretty much what I have here for the night sky tour. Any questions from anybody? Any questions, Justin?
Negative.
Negative. All right. Well, thank you all for listening up on our tour.
And thank you, Derek, for putting that together for us. So, okay, so how are we on the Brandon watch? Oh, I see Brendan Byrne. His name is right under mine in the little thing. Hi, Brendan. Welcome aboard.
Thank you.
Yeah. I'm going to let Trisha actually introduce you. So, Derek, if you can enable her microphone, I'm going to let her talk, and I'm going to be quiet, and I'll let her launch Brendan on his talk. Trisha is our vice president in charge of programs, so she is the one that convinced Brendan to come and speak at our club.
Thanks,
so
Richard.
I'll let her take over from here.
Okay, can you guys hear me okay?
Yes.
Okay. So thank you guys for tuning in. Tonight we have Brendan Byrne. Brendan covers space news for WMFE, and he talks about everything from rocket launches to the latest scientific discoveries in our universe. He hosts a podcast called Are We There Yet? He also is a Florida native. He was born and raised in Broward County, and he moved to Central Florida in 2005 to attend UCF. He began working at WMFE as a college intern, where he discovered his love for public radio. So if you can all help me welcome our speaker for the first ever in the history of CFAS, first virtual general meeting guest speaker, Brendan Byrne.
Thank you. I really appreciate the invitation, and thank you so much for having me. I had a chance to chat with you all a few meetings back, and it was just a wonderful time. So, Tricia, thank you for the invite. Richard, it was not blackmail. It was a very easy ask when Tricia came to me. So I've got a presentation planned. I'm going to see if I can make this work. So let me see if I can share my screen with you all. Oh, it says host disabled participant screen sharing. I might need Derek to let me share my screen here.
You should be good to go, Brennan.
Okay. Oh, there it is. Cool. All right. So you all should now be seeing a great little photograph of my favorite planet, Mars, there. Let me know do I get a thumbs up that we can see that? All right, cool. All right, I'm gonna turn my video off, and we'll get started with this. So as let me see if I can make this work here. There you go. All right. So as Tricia mentioned, my name is Brendan Byrne. I'm a reporter with WMFE and news station WMFV up in the Villages in Ocala, and also a contributor to NPR Science desk. And I cover space. It's pretty much the best job ever, and I plan on keeping this until I die. I tell my coworkers they get my beat over my dead body because it's so much fun. So as Tricia also mentioned, I host a podcast that's now on the air on Tuesday nights, 6:30 p.m. called Are We There Yet? And basically, it's a radio show about space exploration. And we've been doing it for about 4 years now. Over 2 million downloads in 100 different countries, and now we are on your car stereo every day or every Tuesday from 6:30. And the whole point of the podcast was when we first started, we were talking about Mars and human missions to Mars particularly. And my editor and I always had these conversations about, I was pitching stories about going to Mars and all this stuff. And she said, well, are we there yet? Like, when is this actually going to happen? And that was kind of the focus of the podcast, and it's loosely the focus of the show now. Because that is where space agencies and private companies are going to. They want to put humans on Mars. In the short term, we want to go to places like the moon, but the end goal is going to places like Mars. So this show and my reporting kind of looks at space news through that lens. And so I want to go through some of the challenges from what I've learned of doing this show for 4 years, the challenges of putting humans on Mars, and kind of the work that we're doing to make this actually happen. And so for those of you who know me, I actually just finished a book proposal on this. So hopefully next time we talk, I'll have a book written about this, but we'll see. Cross your fingers on that. But first, let's start with getting there. Trisha, all right, thumbs up from Trisha. So at least I got one person that'll buy that book. I'll let the publishers know that. Thank you, Trisha. So let's talk about getting there. You all know this better than I do, as astronomers, that we've gone to the moon and we want to go to Mars, and the moon is far closer to us than Mars, about 240,000 miles, so 250,000 miles away. And the Mars at any given time is, in the hundreds of millions of miles away. So it's a very, very far off place for us to go. So distance is definitely an issue with Mars. Another issue is that our orbits don't always sync up together, right? There's this very small window of when Mars and Earth are the closest to each other. The Mars transfer window, it happens once every, 2 years. That's why you have rovers heading to Mars this year. And so human missions to Mars would have to follow this kind of celestial schedule of when they come together. Now to do that, places like NASA are thinking about these human missions to Mars, and they're working on building the hardware to get us there. This is a mock-up of NASA's Orion space capsule, which will be the first deep space capsule developed by the agency since the Apollo missions of the 1960s. The first iteration of Orion is back at Kennedy Space Center awaiting an uncrewed test flight sometime in 2021. But this is what it will look like. This is the deep space capsule, and it will be flying on NASA's SLS rockets. So if we haven't seen this clip yet, I'm sure if you're space fans, you've seen this clip. I'm going to try to open the chat here and, sorry, folks. Guess I can't do that. All right. We're all learning here. So this is NASA's SLS rocket. So that's the rocket that's currently being slated for use on to take humans to Mars, but first they're going to go to the moon. And that unfortunately that rocket has been delayed due to coronavirus. Testing of the core booster at Michoud in Mississippi has been put on pause. But right now we're looking at a 2021 launch date for a trip around the moon. And then eventually NASA wants that to go to Mars. Now inside that capsule, it's quite small. And so that's one of the issues that we're dealing with going to to Mars is it's a very, very small capsule, and it's a very, very long journey to get there. So I'm sure all of us can understand what it would be like to be stuck with our loved ones in a very tiny capsule like this after we've all been stuck with our loved ones inside recently. But Justin, it is far smaller than the size of your condo. Actually, it's like a minivan. So that's one of the things that we'll have to overcome. One of the challenges there. Another issue is radiation. Deep space will expose our astronauts to just a bombardment of radiation, and that's not good. We'll also have to learn how to deal with living in microgravity for extended period of time. We're talking about a trip of months, if not years, at a time, and microgravity is not good on the human body. We've attempted to study this recently with NASA's twin study. So on the left there is astronaut Mark Kelly, and on the left is astronaut Scott Kelly. They're both identical twins in the astronaut corps. Both have flown on space shuttle missions before. But recently NASA did a study about how Mark's body adapted to living in microgravity and in low Earth orbit for an extended period of time. It's called the Year in Space. It was a little short of a year, 360 some days or 350 some days. And his brother Mark was down here on Earth, and they kind of used as the control, and they compared what happened to the two of them. And there were some very interesting things that happened on this mission. Scott definitely got some muscle degeneration, some bone loss. He had some optical issues. And he also, I had an opportunity to talk with him after it for the podcast. And he said he ended up getting like these weird allergies when he came home. Like he was allergic to his bed sheets. Like he would go to bed and put his sheets on, he'd wake up with rashes and stuff like that. And that was tied to the hyperallergenic filters on the ISS. He wasn't used to these things. So he had a really difficult time coming home. They even found like portions of their DNA had changed due to their time in space. So it was very interesting what happened between these two astronauts, one up in space and one down here on Earth, which doesn't kind of paint a very optimistic picture for long-duration space travel, and then especially if you're going to do long-duration space travel and then land on a very inhospitable world like Mars. So the human physiological issues are going to be a massive challenge for putting humans on Mars. But there is a bit of a bright spot. This is Christina Cook. She recently came back from living almost the same amount of time on the space station. They changed up her mission. She's supposed to be up there for a 6-month mission, and some factors changed it so that she had to stay up there a little bit longer. And she didn't experience as many adverse physiological effects as Scott did. And there's a few different hypotheses around that. One, she's much younger than Scott, and two, she's female. Apparently, the female anatomy does much better at long-duration space travel than the men do, which is very interesting. So a lot of physical science folks are keeping a very keen eye on the studies that are coming from this. So it's great to have Christina back and learning so much from her. I see in the chat someone asked, are there any details on how to mitigate radiation? There are, and we'll talk about that in a little bit in the presentation, but I just want to make sure that you saw that I saw your question. So living there, the red planet is very harsh. We can kind of see here from this great NASA graphic the temperature fluctuations on the surface of Mars. Even the temperature fluctuations on Earth, I wouldn't enjoy them very much. So you can see just how dramatic they are on the surface of Mars. Also, there's not a lot of resources, but there are some resources that we can find. And one of the ideas is to kind of leverage this thing called in situ resource utilization. So this is using what you have and turning it into something that you don't have. So water and oxygen are really things that astronauts will need if they're going to go to Mars or colonize Mars. And there's a lot of really cool experiments happening down here on Earth that take the resources that we have in situ that are at the place you're at and turn them into something that you can use. So water is one of those. If you can find some form of liquid water wherever you are, you can use a chemical reaction called a Sabatier reaction, and you can separate those molecules into hydrogen and oxygen. You can use the hydrogen for rocket fuel. You can use the oxygen for life support. You can also use it for rocket fuel as well. This in situ resource utilization is being applied to missions to the moon with the hopes of being able to use them for places like Mars. But there's also a very interesting experiment happening here at the Kennedy Space Center by a principal investigator by the name of Annie Meyer, and she's taking trash that astronauts would generate and turning them into gas by incinerating them and getting water, which she can separate into hydrogen and oxygen. So it's a very interesting kind of solution to this problem of, well, how do you provide life support? How do you provide fuel? How do you provide drinking water without bringing it with you when you're on a place like the Red Planet? But I think one of the most difficult challenges of getting to Mars is not the physiological, it's not the chemical, it's not the resource utilization. It's something a little bit closer to home, and it's Congress. For any of these missions to succeed, they will need funding from Congress. And even before this whole coronavirus pandemic, it was difficult to get money for these missions. There was a disconnect between the presidential administration and congressional leadership, which is responsible for appropriating money for NASA. And this is an issue that happens in every presidential administration and every Congress. The money's not there, the appetite's not there for these things, and especially when presidential administrations are done after 4 or 8 years. These are missions that last longer than that, so administrations don't want to kind of sign on to these things. So we've had a lot of kind of changes to NASA's directive and money that doesn't get to the hands where it needs to go. So I think after covering this beat for 5 years and producing and hosting the podcast for 4, I think the most difficult challenge of putting humans on Mars is not the physiological challenges or the engineering challenges, but it is the political challenges. I had one lawmaker tell me political science is harder than rocket science, and I would have to agree with him in this respect. But that's not to be a Debbie Downer. You know, is there a bright future for Mars exploration? Absolutely. I think we are kind of seeing a paradigm shift in the space community at large, where space agencies are not running the show, but it is instead the private space industry. And I'm sure we all know who this fella is here. This is Elon Musk, and his company SpaceX is doing some pretty incredible things to propel human space exploration. 4 years ago, I would be very skeptical of anything that Elon Musk said, but after writing headline after headline of what I thought was science fiction is actually science fact, I've really turned around to kind of the incredible things that him and his team can do. SpaceX is an incredible commercial company that is doing really, really fascinating things commercially and making space profitable once again. But they were all set up to colonize Mars. And anytime you talk to Elon Musk, he will remind you that the reason SpaceX exists is to make humans an interplanetary species. This is one of his designs. These are starships that he wants to launch from Earth and bring hundreds of colonists to the Red Planet. And this would look like science fiction until you see some of the work that they're actually doing. This is a recent test of what has been called the water tower. It is a test of its new engine and new tower system, or new tank system, to launch and land So that was test footage from SpaceX, and I'm seeing some folks in the chat here. W. Castro asks, "Is this a real test footage or animation?" That's real test footage. That was a test article that they built to see if their new engine could actually launch and land precision a massive fuel tank. Justin asks, "Is this the Texas facility?" That's the Boca Chica facility there where they're doing a lot of these testing. Starship will launch from Kennedy Space Center is the plan. But this particular test is what's helping build this. I call it the steampunk nightmare, but Elon Musk is building this stainless steel rocket, and since I've created this presentation, sorry, I've got a dog here. We're the joys of working from home. There's a new iteration already from this. So hey Cassie, I'm gonna have to take that from you. There's a yes, Justin knows Cassie. There's a new iteration already on this this spacecraft, and you can kind of see in this picture. I don't know if you can see my pointer here, but this is the first iteration of the Falcon 9 rocket. So we're looking at like 190 feet tall, 200 feet, and then now you're looking at this massive Starship test article here. They're just doing some really cool things. To answer Honey's post, the dog is named Cassie after the Cassini spacecraft. I'll turn my camera on after this presentation, and you can see why. Okay. Bob says let her play. Come here, Cassie. Go over there, baby. We'll let her do her squeaker over there. NASA is free Cassie. NASA is also working on its kind of pathway to Mars, and its pathway is a little bit different than SpaceX's. It plans to use the moon as a proving ground. to learn how to live and work in deep space before it heads to places like Mars. And it's doing that through all sorts of different partners. Right now, the plan is to have a gateway, although those things have changed. Again, I don't know if you can see my mouse here, but here's the lunar gateway. This will live in an interesting orbit around the moon. And from the lunar gateway, commercial lunar landers will connect to it. There are a bunch of different private companies are bidding to make that lander, including Blue Origin and Lockheed Martin. There is another program called the Commercial Lunar Services Payload, CLIPS, which will send robotic surface missions to the moon. There's also Orion. There's at least 3 or 4 scheduled missions of the Orion to go around the moon and eventually land on the moon in 2024. And then there were Mars robotic exploration missions planned as well, like Mars Perseverance, which was previously known as Mars 2020, which is hopefully, fingers crossed, launching this year during a Mars transfer window that we have in play. So this is kind of NASA's holistic approach to getting to Mars. The plan right now is to explore the moon first, use the moon as a proving ground. You camp in your backyard before you go the Appalachian Trail. That's kind of what NASA is doing. Go to the moon first, and then send folks to Mars, where other companies are going, want to go straight to Mars. To talk about some of the challenges that we spoke about earlier in the presentation was space, like literal living space. The Orion capsule is very small. You would not want to be stuck in that with your coworkers for a 20-month trip to the moon, or I'm sorry, to Mars. So there's companies like Bigelow. Bigelow created a inflatable habitat, and here it is. There is a module, a test module of it on the International Space Station right now. It's flat packed, and then you pressurize it, and it gets bigger and bigger and bigger. It's still attached to the International Space Station. It was just supposed to be a test, but the astronauts liked it so much they're using it as storage still. But you can see that it starts flat and then it gets bigger and bigger and bigger. These inflatable habitats are what we're going to need to use for long duration missions to Mars. So you send up these habitats, the Orion spacecraft rendezvous, docks with them, it expands, and you've got a much bigger living space. Once you get to the surface, the Jiffy Pop method, yes, that's exactly what it is, the Jiffy Pop method. Thank you, honey. Once you get to the surface, you can build your own habitats. NASA has been doing an annual competition with college students to build habitats using these kind of underground caves that are already on Mars. So we won't live on the surface of Mars, we'll actually live below the surface like this. In order to build something like this, you would use something like a 3D printer. This is a photo from a relatively new company, pun intended, called Relativity. And these are, over here is a guy named Jordan Noon. He used to work for SpaceX. I've completely forgotten this fellow's name, but he worked for Blue Origin. Tim Ellis is his name. And the two of them, when they were both interns at Blue Origin and SpaceX, talked on the phone a lot. They were both college buddies and talked about additive manufacturing and 3D printing rockets. And so they came up with this business plan, and they are now building their a rocket called Terran 1 that will launch from Cape Canaveral probably next year, that is made completely with 3D printed parts, which is really, really cool. And the neat thing about this is that these machines here that they use, they're utilizing machine learning. So basically what they want to get to a point where you can just put anything in the hopper of these machines, and the machines will figure out a way to turn it into the materials that they need to make rocket parts or hardware or whatnot. So this is definitely a company to look towards to see what they're doing in the short term to address some of these challenges that we've talked about through this presentation. And they're going to launch rockets from Florida in the very near future. So definitely a cool company to watch. If you haven't checked out their website or anything like that, go ahead and look at them. They're really neat. I have a few interviews with Tim and Jordan on my podcast that I'd be happy to share with anybody who's interested. But they have some really interesting ideas, and I think they've got the technology and, more importantly, the funding to pull it off. And then also another really cool thing we've got going on is Mars Perseverance, which launches this year, which is absolutely exciting to see another Mars rover launching, and especially this one, and especially for me, for someone who is involved in radio, this rover will have microphones on board, so we'll actually get to hear what Mars sounds like. And the microphones are not just to, kind of satisfy this, satisfy us with cheesy sounds from Mars. They're actually attached to a laser, and it will listen to the sounds of samples it is hitting with a laser, and they'll be able to determine what it's actually made of, which is really cool. So it's kind of like a form of spectroscopy. And the microphone will also listen to the vehicle itself to hear if there's any issues with it. So kind of like if you hear a clicking on your car and it's time to take it in the shop, the microphone will be listening out for those things. So that's just my little plug to the Mars mic, which is super exciting. So with that, I was going to open it up for questions. If we didn't have the ability to do a Q&A thing here, I will go ahead and stop sharing my screen and turn my video back on. But I don't know about if Justin has some questions or if we want to take some questions in the chat. But
yeah, you were great about answering them as they came up. I was going to queue them up and ask you at the end, but you're following along and knocking them out. So now's a perfect time for anyone to ask in the chat.
I see Barbara asked about Robert Zubrin's Mars Direct Plan. I just bought his book, and I plan on interviewing him for the podcast. But yeah, he's definitely kind of on the forefront of a pretty good plan to get humans to Mars. So he's definitely interesting, folks. Richard asked about using stainless steel for the rockets. Seems heavier than necessary. I don't follow this too closely, but I know that they were going to do carbon fiber tooling, and that took too long. They can reiterate the design faster if it's stainless steel, and they actually invested a lot of money into these carbon fiber tooling facilities, and then just scrap that idea. They can just put the panels up faster that way, as opposed to reiterating design on and retooling or redesigning. They can just cut stainless steel, and apparently it does really good for heat. Yes, as Tom said, the steel they're using handles cryogenic temps better and is much cheaper than composite. So you said that far more poetically than I could, Tom C. Thank you. Thank you for that.
Brendan, just for me, I know you talk to a lot of, kind of cutting edge companies. How far off are we from artificial gravity through space travel? Are we just not even anywhere near that?
I've asked that question a few times, and for you the math behind it, to make it work, it would have to be so massive that it really wouldn't pay off. if you had like something like the International Space Station, right, and the artificial gravity that you would make is, you know, spinning it, right? The centrifugal force would cause you to feel gravity. If you did that on something the size of the space station, you'd be very sick. It would really make you dizzy and make you feel really gross. So you would need something massive to do that, and we're not building things that massively in space just yet. So artificial gravity, in the sense of, you know, these giant space stations that spin at this rate, we're very far off from that.
Physics versus cost of getting
exactly
off the
yeah.
planet.
It's very expensive. It's very expensive.
We had iPad asked about how the Mars rover's powered, if you want to answer that, but without the solar panels.
Yes, and I think Derek answered that sucker is nuclear.
Mm-hmm.
They use RTGs, radiothermonuclear generators, which is basically plutonium decaying, causing heat, and there is a thermoelectric thing that turns that into power. So the same thing that kept Mark Watney warm will keep Perseverance powered on, which is very interesting. There was a shortage of material that you would need for RTGs, but since then the Department of Energy has been able to manufacture it in more quantities, so we can use RTGs as well, which it's a much better way to generate electricity for these rover missions, especially on Mars when you're subjected to, you know, dust storms and all that stuff. So
Bob Vogel was asking about the psychology of close quarters.
I think we're all experts in the psychology of close quarters now. There have been some interesting studies on it. I remember when I first started the podcast, I interviewed a sociologist about living in close quarters on the ISS. They've done some surveys and such like that. It's definitely interesting. You have to kind of. NASA already does some psychological evaluations of people. There are also some isolation studies like the high seas, which was a simulated mission to Mars done on a remote island in Hawaii, where they would take a group of people and put them together for an extended period of time. And it was basically a psychological evaluation of how people live and work together in close quarters for extended periods of time. It's pretty fascinating. On the podcast, I interviewed a few folks. If you Google "life on the high seas" and it's HI-SEAS, I talked with one of those folks, and we approached the topics of isolation and a disconnection from family and living with people for an extended period of time, and it's pretty fascinating.
Wasn't there a situation where someone was electrocuted? There's an emergency.
There was, yeah. So there was another episode I did with the journalist Marina Koren from The Atlantic, and there was an accident where one of the participants was electrocuted, and there was an ethical dilemma as to, well, do we call this off, or do we see how these people that are isolated deal with a medical emergency? And it's a fascinating ethical dilemma. It has definitely put a kink in the high seas mission. I don't think they've had one since then. They lost their NASA funding because of it. But it is definitely a fascinating story, and I would read the Marina Koren story about it, because it's just it really makes you think and pick a side ethically. What would you do? You know, is the Mars simulation worth risking human lives? It's a fascinating conversation.
And Trisha's got a bunch of questions for you. You want to scan down those and kind of
Yes.
cherry pick a couple?
So Trisha says, how would ground-based telescopes work on Mars? I have no idea, Trisha. I'm going to leave that to the experts. How long before you think we have, say, groups of 100 people or more on the surface? We are decades away from that, I think. I think we're decades away from having 2 people on the surface, let about hundreds. How do you think the early Martians will deal with the separation? This was something I really tried to focus in my book. What would you do this far away? And as I mentioned in the presentation, I had the incredible opportunity to chat with Scott Kelly when he came back. And I asked him, I was like, what did you miss the most? And, I'm not sure if anybody knows the story of Scott Kelly, but his brother is Mark Kelly, and his brother Mark Kelly is married to Congresswoman Gabby Giffords. And when he was on the space station, Gabby Giffords was shot by someone at a political rally or a campaign event and almost died. And Scott, this happened while Scott was on the space station. He said that was one of the hardest things, was to not be able to be with my family during this. And he knew he couldn't get down there. There was no way that he could get down there. So he had to deal with this, 250 miles up. But even then, he said the thing that he missed the most was his dog. Like, he missed having that companionship. So, I think those are some things, some big questions we're going to have to think about, putting humans in isolation and so far away. So I don't know how they'll deal with separation. And I don't know if there's anything that you can do to mitigate those things, but it's very interesting. So.
All right. Well, I'm going to pass it back over to Richard and Derek. Brendan, before you hopped on, we talked about all running outside to look at the ISS passing over, and I think we've got about 5 minutes.
Okay.
So I just logged into my phone here. So what I'm going to be doing is I'm going to be sharing my phone and a video of that. So for those that are unable to go out, or we can at least show that on the recording later. I'm going to go outside. So just for those that are interested in going out right now, it's going to be happening at 8:36, starting in the northwest, I believe. Let me go all the way to the top of the meeting page here. Scroll down to the, there we go. Starts 29 degrees above northwest, disappears 16 degrees southeast. So should we take a quick break for everybody to go out and look?
Yeah, I think that's good. I've been watching the time too, Derek. So everybody run outside. The space station's about to fly over. That'd be really cool. And then we'll be back here. We're not done. Thank you, Brendan, for talking to us. But we still have Frank's talk on virtual outreach that I'm looking forward to. And we have a very large number of Astro-photos submitted by members this month. Apparently, everybody's stuck at home. They're doing astrophotography. So that would be very cool to see what our members are up with. So I'm going to mute and turn off my video and run outside, and I'll be back in a few minutes too. So,
and thank you all for the invite. It was so much fun to chat with you all. So
thank you, Brendan.
It's a pleasure.
It was a great talk. Very good talk. Thank you.
All right, everybody. I'm outside my here, and I'm taking a look. I don't know if everybody can see my screen here, but I'm gonna go ahead and mute it for the second. But once I start seeing the International Space Station, I'll go ahead and unmute my video and audio.
All right, looks like we have the International Space Station. It's starting to become visible right now. I don't know if I have the ability to enhance my camera. Oh, it's not focusing. There we go. Come on, focus. Well, my camera unfortunately is not focusing as I was hoping it to be. Oh, come on. There we go. All right. Here. There it is. You can see it's kind of showing up in the image there, sort of. It's kind of visible. Oh well. I was hoping it would work, but alas, it's not. Oh, there it is. All right, so there's the International Space Station right there. You can see it. There it goes. Finally got it. Of course, Venus is on in the below there. Let's see. There it goes. All right, so there goes the International Space Station. 5 miles a second. There it goes. All right. I'm gonna keep talking, otherwise it might not show you it, but there it is. There it goes, the International Space Station. Zoom out a little bit here. There it goes. There's the house there. You can kind of see. All right, there we go. Nice and bright tonight. There it goes. That sunlight reflecting off of those solar panels. I apologize. The camera is really trying hard to pick up the focus. It's trying to fight between the house and the International Space Station, but you can still kind of see it. All right. All right. I think there it goes. Heading out. All right. Still see it there. Going behind one of these houses here. International Space Station. All right. There we go. All right, there we have it.
That was cool. Thank you, Derek. Hope everybody got a chance to run outside and and see that. When I used to teach a night class, I used to teach computer programming out of a school on the other side of town. And in the middle of class, I go, by the way, the space station's flying overhead. And I would take all the students out into the parking lot and I would point at it with my green laser. And they always got a kick out of that. So it's a nice break in the middle of things.
Did anybody actually see the video? Did it actually work?
No, we didn't see anything at all. It was just dead quiet. Were you doing anything?
I was, yeah.
I'm just kidding. No, it was great, Derek. Thank you. Thank you very much. Yeah, no. It was some dead pixels. Yeah, Tricia, I'm sure. No, that was great. So I don't know how much time we should give everybody to run back inside. There's like not really a poll. All our speakers are back. Our video feeds are all live. I guess we should just go ahead and start with the astrophotography showcase, since that may take an hour and a half. Not just kidding. It won't take that long, but we'll go ahead since Derek is back and at his desktop.
All right, let's go ahead and get that set up here. Okay. All right, share screen. All right, can everyone see? All right, so we are, I'll go back real quick. So if you do see your photo, what we're gonna do is you can go ahead and unmute yourself, say who you are, just so we know somebody's talking, and maybe make a little brief information about the pictures that we have here. So, some of us may not be in the audience tonight, so if I don't hear from you, then I will go ahead and make some commentary about it. So let's start with our first image. All right, this is from Laura. Do we have Laura here tonight? I believe I saw her.
I saw her name earlier too.
Yeah, I mean, she might still be outside looking at the International Space Station.
Or her audio may not work.
Let me see here. I'm going to look for her on here. Yeah, she's here. I'm going to unmute you. Laura, can you hear us? We can't unmute her.
I see the Pleiades up there in that shot.
Whoa. Okay. Well, it looks like I can't unmute her. But yeah, so this is her shot. These are from the from the Canaveral Air Station. This is the Mercury Redstone. You can see, see the Pleiades. They're off on the top right-hand side. So some of her really cool nightscapes from her locations out there. Here we have another shot from one of the original train engines that would have pulled some of the rockets. So nice stars in the background there. And then here we have another rocket under the nice dark skies under location over in Canaveral. So I wish she were able to be muted because unmuted because I believe she does stuff with the Canaveral. She does tours and whatnot. So maybe she'll be able to share a little bit.
Is she muted because we set everybody up who's joining to be muted and she's
yeah,
not
but
a
I have
presenter?
the ability to unmute people. I'm not sure why it's not unmuting.
Okay.
It's kind of interesting.
Well, this is only our first time. We'll get it. I have a feeling we'll be going to be doing this again next month. So
yeah. All right. So next shot. This is Mauricio Moreno's picture. Is Mauricio here? If you can, go ahead and put a chat in the box that you're here. So if you're here, go ahead and unmute yourself. I believe you should have the authority still to unmute yourself. You just come in muted. All right. So Mauricio is, I don't think he's here tonight. This is his shot of the Pleiades with Venus. It was an absolutely gorgeous experience for those that got a chance to actually see it. So here we have that. As far as camera details, unfortunately, there's not much in terms of that he provided, but I believe it was with his Canon camera with one of his Canon lenses, and I'm sure he just, it was with a tripod. So again, very nice image of the Pleiades and the planet Venus. This is Leonard Ward's image of, you know, it looks like the full moon, but that's actually not the full moon, I don't think. I think that's actually Venus, I believe, or no?
Yes, that is Venus.
That is
Oh,
Venus.
no, I'm sorry. That is the moon, crescent moon.
Right, yeah.
Oh.
It included the Pleiades, Hyades, the crescent moon, and there was another object down in the bottom right corner, I believe, was Venus.
Okay. Okay, gotcha. Okay. You can, yeah, you can really see the Hyades in this picture here. The head of Taurus, the bull. Very nice, Len. Any other information you'd like to provide for this shot? Technical information?
Oh, I don't remember. I'm sorry.
No worries. Okay. All right. Okay, great. All right, let's go ahead and move on to our next photo. This, I think, is also Len's shot as well.
Yes, I shot, let's see, I believe it was the Jupiter upper right, Saturn,
Yeah,
next one down, and Mars below it.
here it is, yeah. So,
Yes.
and
Unfortunately, I have nothing, no ground to relate to here.
yeah. No worries. Do you remember what lens you used or camera equipment you used?
Yes, that was my Sigma lens on my Canon T1i, and I believe I had that at 100 millimeter.
Okay, great. Looks great. Excellent. All right, next one. This is a shot I took of the Milky Way with the planets, Jupiter, Saturn, and Mars as well, next to the Milky Way sky. This was taken at Bull Creek. Richard joined me at a very, 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 very far distance away from each other. He was kind of off doing his own thing. I was doing my own thing. But he wanted to get some Milky Way photos as well, so we decided to head out there. Nice thing about Bull Creek is you're really the only people out there, except we did see a few trucks. But this is a shot of the Milky Way with this was 35 millimeter for the lens, and this is actually a series of 15 2-minute exposures that I stacked together to create this final image of the planets. A really nice as you can see right here is also the teapot of Sagittarius. We got the lagoon here, the Trifid, the Omega, and the Eagle Nebula, all there in the image there. Of course, the
So you were tracking, Derek?
yes, I was. Yeah.
I didn't see the tracker. When I saw this, I thought, you got this in one shot? Holy crap, my stuff is garbage. Okay, good.
So, but yeah, no, yeah, I love using my Astro Track for this kind of stuff. So, and I stopped it down a little bit so I can get some nice defined stars throughout the entire image. All right, our next image is also another one that I've done. I have the opportunity, Robert Russo, one of our members, was graciously able to donate one of his cameras to us. We are offering some virtual school field trips for schools during this time, and we actually did our first school last week, and we were able to show the students the sun, and I decided to take a video of it. So this is the video that was there during the time of that field trip. So the kids really loved seeing the prominences and talking about how big these prominences, bigger than the planet Earth. So they just freaked out when they learned about that and all that. So again, everybody was really excited about it. This was with a Lunt 60 millimeter double stacked using a ASI 120 monochromatic camera. So this is the result of that. Solar imaging is still, I'm still working on learning the curves on that, but it's still a lot of fun, and it's a great way to do that when you're quarantined at home and you want to do some astronomy stuff. All right, the next, okay, yes, so the next picture is also mine. I threw a couple of the images in here. Last night's pink moon. And I decided to have fun with it. So John Pinto actually commented on one of I think the planetarium Facebook page saying, would it be nice if you annotated this? And I said, yeah, it's a good idea. And so I went ahead and annotated the image. This is actually a series of 3 separate images. I used a CPC 1100 11-inch aplanatic aplanatic Cassegrain to our aplanatic Schnitt to get this image and get some nice detail there. So here we have this image showing all the different specific location, locales, and I decided to continue further and show the location of all the Apollo missions as well. So if anyone would like these images for outreach, just let me know. I could send you the high resolution imagery of this. All right, let's see. Well, okay, this I believe Bill Costring, are you here?
I'm here. Can you hear me?
I can hear you. Yeah.
Okay, so I was out a couple weekends ago, and I decided to do Jupiter and Mars. Scene was not that great, but I was happy to see Io on the left-hand side of Jupiter, with the shadow of Io almost dead center, and the great spot was out as well. So I was pretty happy about that. I'm probably a little out of focus because seeing was not all that great. Shot it with my 9.25-inch telescope with a ASI 224 MC camera, which is a color high-speed type camera. Stacked about 25% of the frames that I got from that video, and did a little bit of processing in Registats, and that's what I come up with. God.
It always happens when you're when
yeah. Somebody's texting me like crazy. So that was it.
All right. Thank you so much, Bill. Any other information you want to bring out about this? Any other technical details?
No, I think that's it, unless you can think of something else.
No, I think that's good. All right. No, great job. I mean, you are the planetary master. So it's good that we got you, that you're out and about and doing some more imaging again.
Yeah, I'm happy about that.
Bill Castro, he did something a little bit more, a little bit different. This is not technically an astrophoto, but I think it's really cool nevertheless. Bill, are you on here?
Yeah, can you hear me?
Yeah, we can, yes. Go ahead and
Yeah.
explain what this is.
I'm showing my age here. This is old school stuff. I don't do any imaging per se, but when I'm seeing things that are interesting, I actually draw this at the eyepiece. And I'm not the greatest artist, as you can see, but just to note to some other club members, just drawing it at the eyepiece helps you remember and focus on more details and remember those details better later on. So just an example, as you can see, I'm not the greatest artist, but I still remember, and looking at this jogs your memories, the details you can see. Makes your observing better.
Sure beats my drawing, that's for sure. I think it's fantastic and a great way, and that's something that maybe we could even offer as an education program, is how to actually maybe do some illustration work at the eyepiece. I think that might kind of revive some of these old practices for people that are, might be interested in doing that.
As a plug to the Astronomical League, if you go on their website, there's some programs there on how to do it and better templates to use as well.
Nice. Fantastic. All right.
I think Springer also has some books on sketching planets and the moon. I bought the one for my Kindle on sketching the moon, but I don't have anything to show for it yet. But there are some resources to kind of teach you how to do that.
Fantastic. All right. What do we have next? This is Fritz's image of the Orion Nebula. He is one of these lucky ones that has his own observatory in his backyard. So go Fritz. Yes, definitely. He's using an 8-inch Ritchie Crichton telescope, and I believe he's also using an ATIC camera. I'm not sure the size or anything, but he did a great job with combining the trapezium and the outer layers of the nebula, and using different tool sets that you can use to blend the images together to get this really nice detail in the nebulosity there. All right, Richard, I think this is yours.
Oh yeah, that's Winter Star Party shot. That's the Rosette Nebula, and I shot that with a 6-inch refractor, my 3-150, and this was with a CCD camera, the Finger Lakes Microline 16200. It is 5.6 hours worth of data, and I collected this at the Winter Star Party just in February. If you have not gone to a star party yet this year, you may be out of luck. So I have some friends who skipped Winter Star Party because they were going to Texas, and the Texas Star Party just got canceled. So I'm not gloating. I'm not. Really, I'm not. But yeah, so I was set up there. We had a lot of clear nights, and at the beginning of the night, I did a little bit of time on the Rosette each night while I was talking to people and doing other stuff. And finally got around to stacking it and processing it a little bit. And here we go, Rosette.
Fantastic, Richard. When is the Texas Star Party happening?
It is not happening.
Well, when is it normally happening?
May. It was scheduled for early May, so it's very tight. Now the hopes are, the next really big star party is Okie Tex, which is at the Oklahoma Panhandle. That's much later this year, but who knows? Second wave, this, that. Who can tell the future right now? Do
you want to quickly talk about NEAF and what they're doing?
Oh, we did. They did a virtual NEAF just this last weekend. If you go to neafexpo.com, you can restream it, and most of the speakers who are going to speak at NEAF gave their presentations online, just like we're doing right here. They had a lot of vendor commercials, and there were some vendor sales. Some of them may be going on where they were marking down product because a lot of the vendors who sell things at the show, they count on those sales, and so not being able to go there, they need your dollars. So you can go and check that out. There was a Woodland Hills telescope they also did some virtual presentations. They had Christopher Go and Adam Block and Tim Russ from Star Trek, and I did a talk. It ended up being 2 hours on the Canon EOS RA, which I also had down at the Winter Star Party, and I showed you one of my RA pictures last month in the Astro-photos. But yeah, everybody and everything is going virtual, including star parties. People like Derek and Justin in the planetarium and Frank are paving the way. In fact, Frank's going to talk a little bit about that when we're done looking at these photos. So I'm looking forward to hearing that as well. There you go. Thanks, Justin, for the link.
All right. This, I believe, is from Ben, I believe. Let's see, is Ben here? I think he's one of the newer members. This is the Monkey Head Nebula. A great image there, narrowband image. I think, and then unfortunately, he didn't give me any information about the technical details here, but he did show me this as a very nice image of that as well. Next one is, I believe, Tom Chitty's image. Tom, I know you're here, right?
Can you hear me?
We can, yes.
Oh, wow. I'm surprised. I didn't think my laptop had a microphone. That's the Jellyfish Nebula taken from my home in the village of Tainsville. I let the focus drift a little bit, as you can tell by the stars, but it was a lot of fun to process. I took images over 2 nights, HA, red, green, and blue, and combined them in PixInsight. I was going to the PixInsight class in San Diego in May, but that got canceled, so my processing skills are just going to have to wait.
Well, I still think it's a great processing, Tom. So, don't beat yourself too much. That's great. I know narrowband is a little more.
Yeah, this is narrowband. Yeah.
Yes.
Yep.
Ben, I guess, doesn't have a microphone. He did say that his image that he took here was with a Celestron 8SE. ASI 1600 camera and 180-second sub exposures. So yeah, there you go. All right, then I think this is also another Ben Powell picture. This is a Thor's helmet located near Canis Minor. Do you happen to have the information about this one, Ben? if you want to go ahead and type that down in the chat box here. It's a Wolf-Rayet star, really cool. This one is same telescope, the Celestron 8 SE, again, 182nd subs, 6 hours total was the image. That's a great job with that one, Ben. This is another Fritz image. We talked about this earlier with the night sky tour. This is M35, followed by the other little NGC open cluster next to it. Again, with his 8-inch Ritchie Crichton with the ATIC camera. Nice detail and color of the stars. So I think, great job with that, that processing detail. You can see some of the interstellar medium in this as well. So, a lot of people, when they process their images, they process it to a point where they stretch it in a way that makes it very dark. However, there's actually a lot of dust and other things in space that a lot of times is not considered when you're processing images. Of course, it's a thing about astrophotography is it's very subjective. It's all based on the person's preference. But as somebody that appreciates showing that space is not dark per se, we just don't see it with our eyes. It's really nice to show that there's so much still out there in space. The NGC object to the upper right, I don't remember the name of it. If anyone has the comment, anyone know the name of that, go ahead and put a comment below. My brain has been on these virtual things all day. So my 2158, thank you, Bob. 2158 is the NGC object above Messier 35. Tom, I believe this is another one of your images.
Yeah, it's NGC 2903 or 2403. I can't remember which. This is the HA RGB image. The jellyfish was SHO, sorry. This is my first attempt at trying the 4 filters together and bringing out the H2 knots. So that's it. Taken with my Spree 120, my Trius 694, and my Mighty Mount.
Nice. Now, can you quickly explain for those that are new what S and what O and HA and all that stuff is, real quick?
SHO is considered the Hubble palette. It's what Hubble or the people who do the Space Science Telescope Institute or whatever they're called publish a lot of the pictures in, where they map sulfur 2 to red, hydrogen alpha to green, and oxygen 3 to blue. And so it's false color, but it really helps define the elements that you're seeing in the picture.
Great, yeah, that's a great explanation. Yeah, narrowband is very, very important when you're looking at emission nebulae and things like that, because it really pops out some of the details and trying to understand the composition of some of these objects. And particularly this galaxy here, very similar to the Triangulum galaxy. It has a lot of what we call HA regions. So those bright red spots that you see there are large clumps of hydrogen gas that will eventually help for the development of stars. So this is a fairly new galaxy, and we know that because we see a lot of red hydrogen alpha layers here, which tell us that this is a very, very hot, rich area of star birth or star formation. So doing narrowband and getting those particular wavelengths of light enhances our ability to see those areas and get a better understanding of how the galaxy, So great job, Tom, with that as well.
Thanks.
All right. Okay, I believe this is Frank Kane's, right, Frank?
Yeah, I think that's mine. That is the globular cluster M53, which is in the Coma Berenices constellation during the wee hours. It's one of the farthest ones away. It's like 60,000 light years away, I think. So it's one of the more distant globs out there. And yeah, I really love me with some globs. This is taken through the 190 millimeter Maksutov Newtonian on a Paramount MIT, and I think it's about 3 hours of RGB data.
Great, thank you. Yeah, it's a great image there. It's really tough to image the inner cores of some of these globular clusters because of the how bright the cores of these globulars can be. So it's nice to have a very defined center there, which can be tricky when doing globular clusters.
Did a good job on that.
Thanks, man.
I think this is also your photo too, isn't it?
It is, yeah. It's not the prettiest thing in the world, but it's really cool. It's a little obscure galaxy group called Hickson 44, and there's 4 like really funky galaxies in there that are 80 million light years away. They're just like really, I really get into these like distant, messed up galaxies, and these are really distant and really messed up. So this is about 9.5 hours of total exposure time through the same rig as before. LRGB data this time, taken over the course of 4 nights.
Yeah, the nice thing about this is that you can really use this as a way to classify galaxies. You know, when you there's the this is generally probably an SBC or spiral barred, very defined spiral arms, so very tightly, not tightly wound. And then you have a general spiral galaxy here, followed by a elliptical galaxy. So a great way to kind of show the difference in other galaxies. Another thing I love about these pictures is that as you zoom in, you can see all these other obscure galaxies around it. So, when you take your images of galaxies, make sure, especially even, not even just galaxies, but other objects, make sure to really take a look, and you might, get what we call galaxy bombing there. So there we go. This is an image I took of M81 and M82, and then there's also this other smaller elliptical galaxy down here. But there's also little obscure galaxies in here as well. Just like with Fritz, I enjoy showcasing the interstellar medium that you see here. All of this dust is actually, imagine kind of wispy clouds in our Milky Way, surrounding our part of the Milky Way galaxy. So think about, being out there on a semi-cloudy, semi-clear night when you have almost like a thin layer of water vapor. This is the same thing. So it really shows you that space, again, is not just as dark that you see in science fiction. There's a lot more out there. The dust can be anything, really. It could be a mixture of organic molecules. It could be alcohols. It could be all kinds of weird stuff. So what's really nice too is I did some enhance some HA information in there to get those hydrogen alpha jets that are radiating from M82 there. So this was with a Canon 6D modified cooled camera and with my 190 millimeter Mac Newtonian reflector on a Orion Atlas mount, and this was about 3 hours worth of exposure time on that. Richard, I could say, I think I said this to a comment with you below, I think that black and white galaxies are very underrated because it creates some really beautiful, dramatic images. So take it away.
Thanks. So I'm working on a project that I'm calling Backyard Galaxies. And the purpose of the project is to show galaxies that can be shot in your backyard. You do not have to go to a dark sky site. All of these were shot from my backyard here in Lake Mary, actually during our lockdown or suggested lockdown period. And what I do is I'm shooting these in monochrome, so there's no light pollution filter, no nebula filter. I'm just using a luminance filter on a monochrome camera. It is a CCD camera. It's the Finger Lakes Microline 16200, which I've been shooting with a lot lately, and these are on my S3 150 and on my a Paramount MX in the backyard. Most of you have seen my Mighty, but I use that mostly for visual now. The MX is it's got my scopes on it back there. So, and they're not these are, some of these are made out of 3-minute exposures, some of these are made out of 5-minute exposures. Under light polluted skies, you literally cannot expose longer than that. You just start losing everything to the background fog. You have to shoot flats. Any dust bunnies and things like that are going to show up really, really bad with light pollution. Nice thing about CCD cameras that an advantage they still have over CMOS is they calibrate very well when it comes to flat field corrections. These are, 3 or 4 hours, not super deep, but, 3 or 4 hours of 5-minute exposures. Let's see, up here in the upper left, this is a galaxy cluster in Draco. It's from top to bottom, it's NGC. I had to make notes. 5981, 5982, and 5985. I have no idea if this has got a name to it. I just found it. It's kind of off the back end of Leo and straight up from Leo's back into Draco. There were these three little galaxies right next to each other, and I thought, oh, that frames up pretty nice. So I captured that. M81 and M82 on the right, on the right top. Derek got. You can see a little bit of the hydrogen alpha streams coming out there, but luminance. The HA gives you that contrast to pick those up. But I thought the galaxy, especially Bode's galaxy, came out pretty nice. You can see quite a bit of detail in the arms, and that's in the northern sky, so it's kind of away from everything. I don't know if it's true or not, but it sure seems like there's a lot less ball games and shopping malls lit up at night, and so that may be contributing some to my success. On the bottom left is it's called the Octopus Galaxy. It's just a really irregular galaxy that I think it looks more like a crab than an octopus, and it's NGC 5033 if you want to look it up in the catalog. And then finally at the bottom on the right it's called the UFO Galaxy, which is NGC 2683, and that's in Lynx. The octopus is in Canis venusati. I can't say it, I'll butcher it. I can't say it as well as, Derek or Bob Vogel will have to say me on that. But this is, I've got, next month I'm going to show you, there's something called the Corona cluster of galaxies. I thought that was appropriate to shoot as well. So I highly recommend shooting monochrome as a starting for learning how to process your data. You only have to process one color channel. With luminance, you don't have to collect as much light to get a good, and really getting a good, clean, well color balanced image is really hard. Whereas with monochrome, it's I don't want to say it's easier because it's still work, but it's only one color channel, and you can learn to calibrate correctly, learn to balance correctly, learn to control noise. So that's one of my soapboxes. People should start with mono before they go color. I mean, these are anybody in this club shooting monochrome should be able to get results that look like this. Really, the hardest thing with getting good color images is getting good color images. In black and white, you have so much more control, and I really think you can bring out a lot more of the contrast, and some of the details really stand out. In fact, I've done color images that I just wasn't happy with, and then I converted them to monochrome, and ended up with a decent monochrome image. Not here, but I've done that a couple of times in the past. Monochrome is awesome. So I think that's all I have to say about that.
All right, excellent. All right, our next image, I believe, is also from Ben. This is the Whale Galaxy, located near M97, which is the Owl Nebula, kind of nearby. Unfortunately, I don't have this NGC number memorized. So if you know the answer to that, this is also a great way to create interaction in the chat box. If you know the NGC number of the Whale Galaxy, go ahead and leave a comment in the chat. And Ben, if you can go ahead and give us any details about this image by commenting in the chat box as well. The NGC object is 4631. 2-hour luminance. This is what Ben said, 1 each RGB. And this is also Caldwell 32 if you plan to use that catalog instead. ASI 1600 for the camera. And were you using your Celestron 8 for this? All right, the 8-inch Celestron. There you go. Oh, there we go. Thank you.
There we go, Tricia.
Information there. He is using an Ioptron CGEM 16. So equatorial right there. All right, and this I think is the final image, and I think this is also Ben's. This is the Leo trio of galaxy, or Leo triplet there. So I'll let him, and I believe it, same telescope, same info as Whale. So same info. So we have the Ioptron CGEM 60 ISI 1600 camera, and 2 hours of luminance on that. So great work on that. All right, well, that pretty much concludes the astro photographs of the month, but we can see that this quarantine has really helped us with astrophotography. I think, Frank, were you the one recently that posted a thing from the BBC about astrophotography?
Yeah, that's right. The whole big article there on bbc.co.uk.
If you're on Facebook group, I believe he posted that to that, so give that a look. The nice thing about astronomy is it generally is a either at a safe distance or kind of a loner pastime. I will say this before we continue on, that I did hear from the people at the Chiefland Astronomy Village, the Billy Dodd Field, that it is open. Should you decide, hey, I want to take it and go up there and set up. The nice thing about Chiefland is it's fairly self-sustaining. You just bring your own food with you and set up a tent or a camper and go out there. So it is open for use. Just of course practice proper safe social distancing practices. So if anyone does want to take advantage of some dark skies coming up in April, you're allowed to do that just as long as you follow the rules effectively. Okay,
thanks, Derek. That's great. I'm so
real quick. Baba was asking, have you done any sky metering? In regards to where to Chiefland, or I've done sky metering at Geneva and of KPP, but I haven't done it at Chiefland actually. But I know that Chiefland is, I think, a Bortle like 4. I think.
I think it would be interesting to do a sky meter now, Derek, here at your house. And then when everything goes back to crazy, do it again.
Yeah.
And see if there really was a difference and the skies were slightly darker. Yeah.
Yeah.
Rob says, yeah, local.
I gotta go, and I'll report back at the next meeting.
Okay, cool. Thanks. So, so we're running a little late. We still have one more program, but hey, you're already home. So, yeah, we're good. Frank is up next. He's going to talk to us about some of the interesting things he's been doing, and I'm not going to get in the way. I'm just going to say, take it away, Frank.
All right, thank you. Let's see if I can share my screen successfully here. Hopefully you are seeing a giant slide that says online outreach. Somebody's yes. Cool. We got a thumbs up. All right. So yeah, I'll keep this kind of quick. We are running late here, but if anyone wants to have follow-up questions afterwards, I'm happy to answer them. Or if you just want to hit me up offline on Facebook or groups.io or whatever works for you, happy to talk about it some more. And yeah, online outreach, it's kind of a hot thing these days for some reason. I don't know why. But can I advance my slide? There we go. Yeah, events like this aren't happening anymore right now. And, you can't really beat, the look into kids' eyes when they see the rings of Saturn the first time in person, but we can't do that right now. But, we were actually thinking about this a year ago, me and my family. How can we actually expand outreach beyond just these physical events? How can we actually transcend the limitations of your local population and share this experience with a larger audience? And sure, it's not the same. You're not going to get to see the look in the kids' eyes necessarily. But there are a lot of benefits to going online as opposed to having an in-person event. You can reach a much larger audience potentially online. You got the entire world population on the internet at your disposal there. Reaching it's harder than it sounds, though. We'll talk about that later. You can also be more opportunistic with the weather. So when you're scheduling an in-person event, you normally need to schedule that out weeks in advance and cross your fingers that the skies will be clear that night. And if it's not, you got to cancel the whole damn thing. But if you're going online, you can just check the weather report today, say, hey, it's going to be clear. I think I'll do something online tonight, and just do it, Broadcast out that you're going to be doing this earlier in the day, and some people will show up, and you can record it and let them watch it later. And that's the other point, too. You can record it. So it doesn't have to be watched live necessarily. People can always consume this content after the fact if they want to. And in my experience, you usually get about twice as many people that will watch this later on as we're watching it live. So not only can you reach a larger audience at the time you're doing it, but it stays there forever. It has sort of this evergreen effect where it can always be out there and reaching people even after you're done with it, which is awesome. And you can still show people stuff through your telescope. You can still preserve that experience of like discovery with people and saying, hey, we're going to look at this cool celestial object through a real telescope together. And we'll talk about how to do that. You can still answer people's questions live. You can do it through comments after the fact as well. So you can still get that interaction online and virtually. And yes, you can still get people excited about the cosmos, even if it's through their computer at home. And obviously that's very relevant right now, and everybody's doing it now. So that's cool. But hey, we were doing it a year ago, just saying. So it doesn't have to be complicated. If you want to try doing this yourself, kind of the easiest thing to do is to just use your cell phone. So if you have a cell phone adapter for your telescope, and if you really want to get fancy, you can have like a tripod adapter, which is this thing on the right here that will hold your telescope on an actual tripod. Stick it there and just sort of film yourself talking about what you're going to be doing. Show your telescope. I think that's important to sort of have this establishing shot that we're really looking at a real telescope here, guys. And, you know, just use your cell phone. If you have an app on your phone for Facebook Live or YouTube or whatever streaming platform you like to use, it will have a little button where you can push it and say, go live, and use your camera on your cell phone to actually stream an experience to the world. And Derek actually did that earlier in this meeting when he went out to actually show the ISS flyover, right? Really simple to do, really easy to do, and very effective. Like that was a really powerful thing, I think, just watching that online. And that's kind of the easiest way to get started. Derek was also doing this yesterday, right? You were doing some imaging of Venus, and you just took your cell phone out, said, hey, I'm out here imaging Venus. Here I am. Here's my telescope. Here's Venus, right? And something as simple as that can be really powerful and impactful for people who are saying, wow, there's a real planet there. Maybe I should go outside and look at it myself. So that can be pretty simple. If you want to kick it up a notch, though, you can. If you have a setup where you're using your PC to control your mounting your camera, and a lot of people who are doing imaging have a setup like this, you can also stream your PC screen directly and sort of give them more of an in-depth look as to what's going on there. So whatever control software you're using, whether it's the SkyX or SharpCap or FireCapture or SGP, whatever floats your boat, you can sort of like, you know, control your scope and show the images that are coming in from your camera live and talk about what's going on in real time. And if you were on the CFAS closed group last night, I was actually doing a little bit of this live last night with the comet, the Atlas Comet C29Y4. I'll show you some more of that at the end of this presentation. And I could have talked about it while I was showing it. I chose not to, but that's kind of what we're talking about here. Just stream your screen. If you have a computer-controlled telescope where you're actually streaming it in through a laptop or a tablet that can then be streamed online. And to actually do the streaming itself, Skype and Zoom can do it, obviously. We're doing it right now with Zoom. Also, Facebook Live, if you run that in your browser, can also share your screen as well directly from Facebook on the web, which is pretty cool too. Just make sure that you have a solid internet connection if you're going to be doing this. If you are actually like attaching a laptop to your telescope outside, you got to make sure you have a really, really strong internet connection out there. Wi-Fi tends to really break down in these situations. And I swear it can sense that you're doing a live stream. And it says, I'm going to break down right now. I'm going to choke. So, you know, make sure you have a really good repeater out there, or even better, a wired connection to make sure that you can do this reliably, or else you'll have a bad experience. If you want to kick it up even further, level 3. So let's say that you have a setup like mine where you can actually control your telescope remotely from inside the house. So right now from my home office here, I actually have the ability to control my telescope out on the driveway and have it point at whatever I want to interactively. So because I can do that, I have all the disposal of a real studio here, as you can see, that I can use to have an even better streaming online experience. So I can have like fancy lights, I can have a nice microphone, I can be seated at a desk and have like real video editing software here that I can use to make things look really nice and shiny. And again, you need to make sure you have a very stable, not only an internet connection, but a stable connection between your home office and the system outside. That tends to be the weakest link in this particular setup. But it is a lot easier if you can just like sit in the comfort of your office here and kind of like manage the stream remotely that way. And this is how we're doing these live events every Friday with the planetarium with Derek and Justin. We've been collaborating on this for the past couple of weeks now. It's been pretty successful. We've had obviously technical glitches always crop up at the last minute, but we've plowed through them. It's been a good experience. And yeah, we've just been using Zoom for this. So, we're just like switching around, like sharing our screen. So we'll use Zoom to sort of like do sort of the talk show aspect of it. And Derek will share his screen to do the planetarium tour like we saw earlier in today's meeting. And then I'll share my screen showing the SkyX and actually showing, we're going to be slewing to this, this target. Let's do some live stacking of it and share that image live with the audience there. And you can actually see an image of that here from one of our more recent, actually this is from our first show, I think a couple of Fridays ago, where we were taking a look at Bode's Galaxy M81 and the Cigar Galaxy M82. That's a live view through the telescope right there that we were actually showing, live to an audience of over 1,000 people live and 2,000 people after the fact. So think about that for a minute, guys. That's a much bigger audience than you're going to get at your typical, local outreach event. So the reach there is really, really awesome. And people seem to be pretty engaged with it too. If you're going to be using Zoom for something like this, you can even include remote guests and tune in on Friday night. We have a special remote guest. I don't know if you want to talk about that, Derek, and sort of spoil the surprise or not, but it is relevant to CFAS members.
Yes, so I will say that he is a person that you all know, or not all of you, because some of you are new, but he's been with the planetarium for many, many years, and he's joining us this Friday to talk about the planets. And we're going to not only be doing some viewing through the telescope, but we're also going to be utilizing some planetarium software to tour those planets and just have a good time. So yeah, join us on this Friday, get a chance to be reunited. And I'm not going to give it away. Hopefully you got the clues. If you've known us for quite a while, you know who we're talking about here. So again, hope that you're able to join us this Friday.
Yeah, Friday at 9. So it'll be a special one for our CFAS members. And the other benefit of having sort of this format where we have multiple people kind of like going back and forth on Zoom is that they can fill in for each other when, you have to do something or something goes wrong. So things might look like they're going smoothly on these things on Friday nights, but behind the scenes, I'm like going nuts here dealing with like, oh my gosh, this thing's behind a cloud, or, oh my gosh, this thing didn't point at the right thing. So you don't see any of that because, Derek and Justin are talking about stuff while I'm not showing you any of that stuff. So it's very good to have people that can cover for you while you're dealing with the technical glitches that are inevitably come up. And the other cool thing too is if you're using Zoom, you can actually use Zoom to stream to social media directly. So if you have I think this might be a pro level feature, but it can actually stream straight to Facebook Live. And that's how we're actually producing these events. We're using Zoom between the presenters to actually create the stream and, manage the content. And then we're broadcasting that out to Facebook Live to the planetarium's Facebook page at the same time. So that's how that works. And at the same time, we're saving the video content as a MP4 file that we can then upload to YouTube and other platforms as well to have an even greater reach. So even better. And if you want to go even crazier, you can kick it up yet another notch before. Ooh, I forgot about this slide first. So this is sort of a high level setup of how this works with the current setup with the planetarium shows. So basically on the left here, we have what's out of my driveway. So we have the telescope, fondly known as Scopy McScopeface. And sitting literally on top of this telescope is a mini PC. It's an Intel NUC, and that's what's actually running the SkyX, which is controlling the telescope itself and the mount and the camera and the focuser and everything else attached to the telescope. Also out here in the driveway, I have a camera, which is really just my cell phone sitting on a tripod, running an app that makes it look like a webcam. Okay, that's all it is. And we call this the live scope cam. And this is actually kind of important because it gives us this establishing shot that I can cut to saying, hey, here's a picture, a live picture of the actual telescope in my driveway. This thing is real. There's an actual real telescope here that's under my control. I can show you it moving around in response to my commands. And I think that really helps people understand that, you're actually looking through a telescope here and not some, pre-recorded, image that's coming from the internet or something like that. So that just kind of helps keep it real with people. I then have a network connection between the driveway and my home office. And we're just using the remote desktop protocol, RDP, to actually do that. That's a free feature that's built into Windows 10 Professional that you can use. I find it's a lot more reliable than TeamViewer and some other alternatives. But again, you need to make sure that network connection is rock solid. When I was first starting this sort of stuff a year ago, this was always the thing that broke. I used to have a Wi-Fi connection out there, didn't work reliably, froze up on me. I put a repeater out there, still didn't work reliably, froze up all the time. What I ended up having to do was get one of those little gizmos that actually transmits network data over your power lines. And so over the same power line that's powering the telescope, I'm actually using that as a network line as well. And that ended up working out pretty well. And this ultimately connects to the system that's here in my office. So we have my desktop system here, which in turn has a webcam that I'm looking at you now through, and a fancy microphone that I can use. So that's kind of controlling the stream itself and the telescope outside. So if you want to kick it up even further, You can use like fancy pants video production software. One is called OBS Studio. There's also a version of it called Streamlabs OBS. That's pretty much the same thing. It's just geared more towards streaming. I use both. But the advantage of using something like this software is that it lets you create these scenes ahead of time. So it makes it easy to have like, you know, pre-generated introductory segments or videos that you want to pepper in, or, you know, these lower third graphics, kind of like, you know, saying what you're looking at. So it just lets you create a more professional looking TV show kind of style for your production there. And this does require a little bit more of work ahead of time. So, you know, you need to spend some of the day before you actually do your event hunting down like free animations from NASA and ESA to actually accompany your live show, images that you want to show, and, you know, any intro or outro segments that you want to include with the show. So, you know, here we're showing the outro segment where when we were doing this on YouTube last year, we'd always end with kind of like a cosmic quote, if you will. And these were all generated ahead of time in OBS Studio. I could just push a button here literally within this list of scenes to actually bring that up when we were done with the production and close the show on that. And if you want to see some examples of this, you can head over to my website at boldly-going.com. Up at the top, you'll see a link for Watch Our Live Star Parties. And you can see the stuff that my family was doing last year on YouTube with this kind of setup. And real quick, I have an example of one of those. I'm not going to make you watch the whole thing, obviously, but you know, just a minute, I'm going to jump around here to some interesting parts to show you what's possible when you put all these pieces together. So, you know, in this case, I've brought in my family, my wife, Carrie, and daughter, Tori. So good to have a nice diverse group there so you can identify with more people. Let me turn myself down here. And, you know, we start off with this view inside the office here just to say, hey, we're real human beings. Hey, hi, you should relate to us. We're nice people. And we're nerds. We have Star Trek junk in here. And from there, you know, we give a little bit of introduction about ourselves. And I'll skip ahead a little bit here. Here's that establishing shot of the telescope in the driveway I was talking about. So right here, we have our live scope cam. You can see it's a live picture. We're pointing at, right now, the Pinwheel Galaxy, I think it is. And that just lets people say, hey, this is real. Now I'm cutting back to my control software, which is actually running on the PC on top of my telescope and slewing to the target that I'm going to look at tonight. And then we have an inlay, again, created in OBS Studio, so people can actually watch the telescope move to that target in real time. How cool is that, right? People love that stuff. And once we get on there, we start doing some live stacking so people can actually start viewing this object in real time together with us with our witty commentary, right? So I'll skip ahead a little bit for that. And once that comes in, so at this point, I've like kicked off the first frame of our live stack. And while we're waiting for that to come in, I have some pre-recorded filler material kind of telling people where this thing is in the sky. So instead of looking at a blank screen for 30 seconds, instead we're going to cut to a little description of where this thing is. And you can see here that we kind of cut to a picture of the Big Dipper there and where M101 is relative to the Big Dipper. And we talk about that for a little bit while we wait for that first initial bit of images to come in from the telescope. And if I skip ahead a little bit more, we see that we have some imagery actually coming in. And as the show progresses, you know, this image just starts getting better and better over time. And you want to like let this get as good as it can get, right? So really for a half-hour show, I'm going to let this thing sit on it for a half an hour. In this particular case, the stars started streaking. So behind the scenes, I like let them talk for a little bit and restarted it to get a crisp image again. So again, you gotta like be ready for things to go wrong. And while we were doing that, we cut to some animations. So we had some like imagery from the Hubble that we looked at. We had some animations that were from NASA, from the Hubble telescope that we could look at, and some Chandra X-ray coverage as well. So you get the idea. You know, you have this like really wide variety of content that you can talk about with the target that you're looking at. And at the same time, we're looking at it in real time together. So as we go through this event, the Pinwheel Galaxy just gets better and better and more clear over time. So that's the general idea. If you want more details about how this all works from a technical level, I did put a blog post up on my website, again at boldly-going.com. If you scroll down to the June 1st section of the website, look for an article that says Boldly Going Webcast Behind the Scenes, and we'll get into all the nitty-gritty details of how this all works if you're so interested. Yeah. So if you do choose to do something like this yourself, there are some things I've learned the hard way that you don't have to, because I'm going to share them with you. Again, make sure you have a reliable internet connection, reliable network connection to whatever you're controlling. That is the most important thing. That is what will go wrong. I cannot tell you how many early attempts at doing this got ruined because of a network issue. So make sure you get that nailed down first. Again, you want to include this establishing shot if you can of the telescope itself so people get that it's a real telescope and it feels like they're really there. And if you're going to do a live stream, make sure you announce it ahead of time if you can. So if you do have any existing followers on your social media, they'll know to like tune in at 9 o'clock and check out what you're doing. But make sure you leave yourself enough time to deal with problems, because there will be problems. I guarantee it. So don't tell them that I'm going to start as soon as the sun goes down. Give yourself time to actually align your telescope, deal with the inevitable problems of, your filter wheel stopped working, your camera stopped working, you have to swap it out with another camera. That's what happened the first week we did this with the planetarium, by the way. I was scrambling like you wouldn't believe, but we made it work. And also, if you are building a new audience from scratch, if you don't have an existing following on YouTube or Facebook or whatever it is, manage your expectations. It's very hard to build a new audience from nothing these days. And that's kind of why we stopped doing this on YouTube last year, because despite our best efforts, I couldn't get beyond like 100 or 200 viewers for a given episode. And, that's, on par with a live event that you would get. So it's not bad. I'm happy with that. But I was hoping for more, and we really struggled to grow that. YouTube in particular is really, really, really hard to grow an audience with astronomy related content. People want to see other stuff on there, and the algorithms reward other stuff on there. So set your expectations realistically when you're starting, okay? Also, be careful with copyrighted content. Make sure that any videos or images that you include in your live stream are public domain or your own. Otherwise, you will get in trouble. There are automated things out there that look for copyrighted content and automatically do bad things to you if you don't follow the rules there. Again, have guests if possible. That makes things more interesting and gives you someone that can cover up for you while you're dealing with problems behind the scenes. If possible, have a moderator for managing live Q&A. And hopefully Justin's still on and keeping an eye on any questions that I might have, because I'm not looking at the chat right now. Finally, you don't have to do it all live. If you don't want to do it live, you can always record it and upload it later. That's okay. I'm not going to tell anyone. It's all cool. And if you can do a dry run the night before, that's always a good idea too, because nothing's worse than saying we're going to look at this object, and then when you actually go to look at it, it's behind a tree. So make sure it's not behind a tree before you actually do this. Anyway, again, a little plug for the planetarium. If you look at their Facebook page, Friday night at 9 p.m., we will be live streaming again. This one's going to be more focused on the planets. And I won't be doing any live stacking on this one. We've actually got some canned planetary imagery work that Derek's put together instead. But I'll be there, being the Flavor Flav to his Chuck D or whatever, and kind of keeping it going there. But again, we have a special guest planned for Friday night, so don't miss that one. Another thing that we're doing on these planetarium live star parties is keeping an eye on the comet C2019 Y4 Atlas. And these are actually a couple of images from the past couple of weeks. So the image on your left is actually the image of Comet Atlas that we showed during last week's show on Friday night. And the one on the right was taken last night. And this is not scientific, these are not taken under the same conditions. They weren't processed exactly the same way, but I tried to tease out the comet as best I could in each one. And rumor has it that it is starting to break up potentially, because we're starting to see a decrease in brightness when it should be increasing. And I think if you compare these two images, yeah, it seems a little bit less distinct on the right one, doesn't it? So I think we're already starting to see this thing maybe fizzle out, unfortunately, which is kind of a bummer, because it had the potential to be a really bright comet as it approached the sun. So we'll continue to monitor it. It could get interesting with like visible fragmentation. I don't know, or it might just fade away into nothing. But we'll keep an eye on it every week, and we'll keep revisiting this comet on Friday nights for as long as we can. And I think that's all I got. So if there are any questions from the peanut gallery, I will stop sharing my screen. And
we
cats.
Didn't have any while you were going, but anyone now throw it out there.
Everything is better with cats. Yes, we have definitely had some surprise cat guests in our stream on YouTube last year. That's another tip I should put in. If you have cats and you don't want them crawling on your keyboard during the show, close the door to your office first. Cool.
Okay. Well, thank you very much, Frank. That was really cool. And thank you, Derek and Justin, for all of your hard work too, putting together your mini programs as well as hosting this. we've gone late. I think we'd get tarred and feathered if we did this in the planetarium. So I'm just going to say, you're already home, so you don't have to be careful driving home and whatnot. So thank you for joining us, though, tonight. We still have quite a few people I see are still online, so you guys hung out and with us. We're almost certainly going to have to do this at least one more time, so we do appreciate constructive feedback. If there's anything that you think worked really well or did not, please let us know. We'll monitor the Facebook pages for that sort of thing, I guess, or you can email us directly, or we can have a discussion on Groups.io about it. So, Lynn Ward's still 30 minutes from home. Sorry, Lynn. So that is it. So good night, everybody, and thank you for joining us. And stay safe, and hope to see you all soon.
Good night, everybody.
Good night.
Good night, everybody. Thanks so much.
Good night.
Good night.
Good night, Jim Bob. Good night, John Boy.